To understand integral equations, we often need to turn them into differential equations, which are easier to solve. And to do that, we have to take the derivative of an integral. So if we introduce a function f of x, which is equals to g of x to h of x f of x t dt, where x is the main variable, t is the dummy variable, and f of x t is the curve, that is the function we are integrating, and g of x and h of x are the upper and the lower limits respectively. So to do that, we have the Leibniz rule, and to take the derivative of a function which is f prime of x, which is written as f prime of x, which is d by dx of that function, which is equals to f of x comma h of x into d by dx of h of x. That is, plug the top limit in and then multiply it by the derivative of that top limit. Similarly, subtract by doing the same for the bottom limit. Plug the bottom limit into the inside function and then multiply by the derivative of that bottom limit, and then add the integral of the derivative of the inside function with respect to x. So this is, however, there is a shortcut here. Look at the function inside the integral. We have square root of 1 plus t whole cube dt. There is no letter x inside it. It has only t. So when we take the derivative of it with respect to x, it will become 0 because it has only t with respect to inside it. So because of this, the third step, that is taking the derivative of the inside with respect to x, it will just become 0. So our simplified rule is just this, that is, derivative is equals to plug the top limit in into the derivative of top minus plug the bottom limit in into the derivative of bottom. And here's the step-by-step solution for this question. F prime of x, which is d by dx of this whole function. And first what we have to do is we have to apply the simplified rule, that is this. And we will substitute t with the top limit cos x and then substitute t with the bottom limit sin x. So we get 1 plus top limit whole cube square root and then d by dx of the top limit minus square root of 1 plus bottom limit whole cube into the d by dx of the bottom limit. And we have to just replace the words with the actual limits from the integral. So the top limit from the integral is cos x, and similarly top limit is the cos x, and the bottom limit from the integral is the sin x, and then we have to take the derivative of the sin x. Then once we have found the derivatives, just replace the values. The derivative of cos x is minus sin x and the derivative of sin x is cos x, and finally we just rearrange the values to make it look neat, and this is the final answer.